Hi all, welcome to day 15 of Advent of Elixir. Today we're going to deep dive into exception handling in Elixir. First, let's go over the basics. Most Elixir resources will tell you that there are two types of exceptions, raises and throws. So let's start by taking a look at the first one, which is a raise. So the most basic type of raise is a raise where you specify some sort of string. Something wrong happened. So let's recompile and run advent.oops. So you can see that we have raised a runtime error with the statement that something wrong has happened. We can also trigger a raise by actually doing something wrong. So let's do this. And here we have an arithmetic error, bad argument in arithmetic expression 3 plus foo. That makes sense. You can't add strings to numbers. Well, not in Elixir anyways. So both of these are raises. And let's go ahead and trap the raise. So how do we trap raises? What we do is we wrap it in a try block. And to trap raises, we use rescue. We can rescue by pattern matching against the error. And in this case, I'm going to not do anything with it. And just to show you that the result of the try block expression is going to be whatever we put on the right-hand side of this arrow. So right-hand side. So recompile this and then run it again. And you can see that the result was right-hand side because we pattern matched against anything. I'm just going to go ahead and make this E, so that what we're going to wind up doing is we're going to wind up returning the error that got raised. And here, you can see we wound up raising something that is a struct of type of module runtime error with the message something wrong happened. Conversely, if I try to do this 3 plus foo business, we're going to get arithmetic error with the message bad argument in arithmetic expression. This message roughly corresponds to parts that we see here in this arithmetic error message that we see here. But note that this arithmetic error message corresponds to this arithmetic error struct. Raises are actually pretty powerful. We can also make custom raises, right? So let's make a custom exception. And the way we do that is we do def exception. And then we put in whatever fields of metadata we want to have. In this case, I'm just going to use message. And what I'll do is I'll create a default message here. And then I'm just going to raise my error. So I can also put in the name of the module that corresponds to this struct. So let's recompile. And then what you can see is that when we run advent.oops, we get exactly the struct as if this were a def struct instead of a def exception. Message, some default message. We can also add the metadata here. And then when we run it, instead of saying the default message, it'll have the metadata, the message metadata that we put right here instead. Okay. Let's take a little bit more of a deep dive into what is going on with this struct. So let's take a look at this. So we're going to inspect the previous result and turn structs off. And when we turn structs off, instead of doing the pretty format for the struct, it's going to just show us what it looks like raw. So here we see that indeed it is a struct with advent.myError as the module. And we have this special field called exception true. And finally, the contents, the metadata contents, are exactly what we specified up here. So we could, for example, do number 3, recompile, and then run this again. And you can see that the number 3 now appears inside of the exception struct. So in short, arrays is always a struct. This is an Elixir struct. It's got a little bit of extra metadata. And as it turns out, that there's also like a few extra functions that come into play. So the advent.myError module has a message function, which when operated on with the error message, it can take the contents of the struct and turn it into some sort of human readable message. Now, you're really intended to override this internally. So you would probably do something like def message, and then we could say override it and make it say only ever have this message. And if we were to say do that and not try catch it, oops, and if we were to run advent.oops, you would only ever have this message, and that would override the message field. But the default implementation of message just looks to see if there's a message field in the error metadata, and it'll print that out. Okay, but let's just go back to normal errors for a moment. And note that in this case, when we raise a standard error, which is runtime error, this also has the special metadata with exception true. And if we were to also do the 3 plus foo instead, the arithmetic error struct also has this exception true special secret hidden field inside of it. So that's raising. Let's really quickly also talk about throws. So instead of raising, one thing we can do is we can do a throw. So let's throw some content. And if we run advent.oops, instead of an error here, it says throw some content. So this is a different type of thing. Note that what happens if we try to rescue a throw. It doesn't get rescued. This throw some content completely fails. Completely fails to be trapped by this rescue statement. The way you're supposed to rescue, the way you're supposed to trap a throw is to use the catch statement. And let's go ahead and do a catch on this error. What you can see here is that we got some content, which is what we put after the throw. And in fact, it's not like arrays at all. It doesn't get converted into any sort of struct. This is just literally the term that we passed in. We could put in some strange term, like say a tuple with an atom as the first item. And if we were to run this, we would catch this term some content. Now, the intended use case for catch is for you to be able to exfiltrate information out of deeply nested function calls. For example, if you were to do some sort of crazy enum and inside of another enum, you do something else, but you know that there's a case when you might have an early exit where you have a definitely known result, then you're supposed to use the throw to bypass having to complete all of those enums, and you can catch it on the other side using the catch statement. Or if you have a deeply nested set of functions, maybe they're recursively parsing some sort of tree, and you don't want to have to complete parsing the entire tree before you come out and say, hey, something didn't quite match up. That's how you're supposed to use this throw catch, and that's why this throw has to be able to throw any sort of value and have that value be caught. While we're at it, one thing I would like to do is to see what happens if we try to raise with something that isn't a string or an atom that corresponds to a module. So suppose we were to try to do this, and then run advent.oops, and we see we get this message, raise.1, expect a module name, string, or exception as the first argument, and we got this weird term, some content, which it doesn't like. So this is really important. Raise in the way that is in Elixir is an Elixir specific thing. It requires structs, and it requires the special exception magic bit of the hidden piece of the exception structs, and it's a very Elixir specific thing. Meanwhile, raises or throws are an Erlang exception, and they can take arbitrary types of terms for what their payload is. We saw how rescues fail to pick up off of throws, and you have to use catches to pick up off of a throw. However, recovering from a raise also cannot be done with catch, and I'm going to demonstrate that right now by changing this code up here. So we're going to raise a normal Erlang error or Elixir error and try to catch it, and what we'll see is that we'll get an error exception. And you see something wrong happened with the runtime error. Okay, so that's the basics of raises and throws. There's actually a third type of exception, and it's called exit. So you're supposed to use exits to exit out of a process when something irrecoverably wrong has happened, and you're inside of the process and you don't necessarily want to try and kill it by sending an exit message. So let's take a look at how that looks. First of all, we're going to just nuke all of this, and then we're just going to run an exit by itself. And that's what it looks like. Exit, something wrong happened. Well, can we catch this with a catch statement? No, we can't. A catch statement will fail to trap on exit. What about a rescue? A rescue will also fail to catch this exit statement. So note that it's not possible to trap an exit using the normal rescue or catch mechanisms in a try-do block. Well, that's not entirely true. There is a second type of catch statement. And this type of catch statement takes two arguments, A, B, And what this will do is the A value will be the type of exit, and the B value will be the payload of the exit. So let's demonstrate this by turning this into a tuple, and then so we can see what comes out of this. So here you can see the A value was the atom exit, and the B value was something wrong happened, which is exactly the payload of the exit. Let's see what happens when we do this with a throw. Now it says throw, and something wrong happened. And what happens if we do raise? It says error, and the payload is exactly that struct that came out of there, the runtime error struct. Okay, so this catch AB is kind of like the low-level form that the rescue and the catch with a single trap are sort of built up on top of. And so, as it turns out, if you want to try and capture multiple things, you need to do rescue first, then write your rescue code there, then you do a catch with one thing and write your code there, and then you can do catch with two things and write your code there. And remember, these are all matches. So for example, I could do a catch on only throws, right? And then if I were to try to raise, because the raise is of type error, if I do this, then it will fail to capture if something wrong happened. But if I do error, then I will get the struct runtime error message, something wrong happened. So the most general way to catch exceptions in Elixir is to use this catch. I do want to show you something a little bit interesting, to me anyways. And what happens if you do this? So remember before, when we did 3 plus foo, it would capture a arithmetic error struct. But note that if we do this, we're going to go ahead and do the tuple here just to. So we got error as we expect, and then instead we got this atom bad arith. You might have expected to see an arithmetic error struct, but instead we got this bad arith atom. And what's going on here is that Erlang actually only throws bad arith atom or raises the bad arith atom as the error. And what happens is that Elixir knows a certain subset of Erlang default error atoms and error values. Basically, these are values that it knows that the Erlang standard library, or OTP, will return as errors that need to be converted into Elixir structs. So in the process of rescue can also identify certain classes of these errors. And instead of putting back a somewhat unhelpful bad arith message, what it can do is it can provide you with a more structured information data type that is part of why Elixir has such good usability. You might, however, also wonder what actually happened to all of that content that we saw. Where did that come from? If catch AB is the generalization of rescue, how did rescue get that information? Well, one way we can get at it is by looking at the stack trace. So let's recompile this one more time, and then take a look at what happens when we run advent.oops. And here is where you can see this information. So the bad arithmetic error contains 3 comma foo as its parameters. So that's how it knew what the function that failed was. And Erlang modules plus function is the function that failed. And there's also this error info metadata, and it says module is URL or its errors. And it turns out that URL or its errors contains a set of functions that you can pass the function in, and as well as the bad arith atom, and it will be able to convert that into a user readable message. So that's kind of a pretty detailed overview of what's going on when you're handling errors in Elixir. I know there's a lot of confusing stuff in here, and that's partly because a lot of this content is legacy. Elixir did a very good job of sort of smoothing over the entire system and bringing the Erlang system into compatibility with the way that Elixir wants to have structured data types and its structs, and how error exceptions in Elixir are themselves special types of structs. And then what's nice is that in response to some of these innovations that Elixir has brought to the usability of the Beam, Erlang has begun to adopt more structured errors and error metadata, and it's been a process of bringing those innovations that have been implemented at the low level into Beam into compatibility with the system that already exists in Elixir. So I think this is a really exciting time to be developing for the Beam, because you'll see all these innovations that Elixir starts piloting out and looking forward to being worked back into the Beam, not necessarily using the same mechanisms, but in such a way that all of the languages in the Beam ecosystem can benefit from these advancements. Okay, so that's all I've got. Have a good day, and I will see you tomorrow.